Mars Express, Europe's mission to the Red Planet, celebrates 10 years in orbit this month. Originally only intended to be 687 days long, the equivalent of one Martian year, the mission has sent back such large quantities of invaluable data that it's been extended until at least the end of 2014. With its 6 onboard instruments, the spacecraft has been monitoring all aspects of the Martian environment, from the subsurface to the upper atmosphere and beyond to its 2 tiny moons. This has provided an in-depth analysis of the history of the planet, with some notable highlights along the way. One of the most important findings was the quantity of ice at the North and South Polar regions. With its ground-penetrating radar MARSIS, Mars Express was able to measure the vertical depth of the ice down to 3.7 kilometers at the South Pole and 2 kilometers at the North Pole. This means that at the South Pole alone there is enough water locked in to cover the entire planet with a layer of water 11 meters deep. Mars Express was able to go further and determine what kind of ice it was.
Thanks to the specific instrumentation on board the mission, we are able to tell us what kind of ice did we find. And the result is that there is a mix of CO2 ice or carbon dioxide ice and water ice. One of the main objectives of any mission to Mars is to trace the water on Mars in every form, liquid if possible, solid, water vapor. So it's very important to study the ice because it's one of the reservoirs of water on the planet.
Another of the mission's most intriguing and debated observations has been the detection of methane in the planet's atmosphere. On Earth, methane is the byproduct of biological or geological processes, and its detection on Mars has led to an intense debate as to its potential source.
Mars Express has, for the first time, detected methane, and also the concentration in the atmosphere vary from a place to another, from a season to another. And this discovery has been very debated in the scientific community because, in fact, methane should not be there because it's being destroyed in the atmosphere by the ultraviolet radiation.
A possible source of the methane could be volcanic activity, although until recently it was thought that the planet's volcanoes, some of the largest in the universe, have been inactive for billions of years. Recent images from Mars Express high-resolution camera show something different.
Some of the volcanoes are in fact very, very recent. We have found some parts of volcanoes that were recent as early as a few million years ago, which is very young in terms of geological ages. So that means that Mars is maybe still active and that volcanoes can well erupt tomorrow.
Finally, to mark the mission's 10-year anniversary, ESA is releasing comprehensive mineralogical maps of the entire planet's surface. These global maps are an invaluable tool as they show the mineral composition of any one point on the planet's surface, which in turn makes it possible to derive the entire history of Mars from this map. Mars Express is also paving the way for the next generation of European-led Mars exploration missions called ExoMars. Its orbiter, due to launch in 2016, will build on the measurements of the atmosphere taken by Mars Express with a focus on determining the source of methane. Mars Express is also involved in finding the best landing place for the second stage of ExoMars, the landing rover due to launch in 2018. Both phases of ExoMars continue the main work of Mars Express to find out whether life has ever existed on Mars or is still active today, questions that have fascinated scientists and the public alike for many years.